On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at another optimization problem that deals with the perimeter and area of a rectangle. I encourage you to watch this video here first, where we have a similar example, but the calculus is going to be a little bit different, where we work with our perimeter and our area. In this example here, John still has 100 feet of fencing. He still wants to make a rectangular pen for his dogs with the back of his house serving as one of the sides of the rectangle. The house is 120 feet long. What is the maximum area of the rectangular pen that John can make? Again, please check out that first video before going into this example here. Now, the back of the house is 120 feet long. Basically, all that's there is to tell us if he wanted to, if John wanted to make, a pen that was, let's say, 98 feet long, and he would have 1 foot for this side and 1 foot for this side, he would use 100 feet of fencing right there. But that would be crazy because the area of that rectangle would only be 98 times 1, which is 98. The back side of his house is plenty long for him to use any length for one of his sides of his rectangle. That's the only reason why that information is there. Now let's give some variables to this rectangle. This is our dog pen right here. So we only have 3 sides since we're using the back of the house for one side. I'm gonna call this side X, which means this side would be X, and this side here we can call it Y. It may be different, it may be the same. It turns out it will be different here. Now, even though we're not talking about perimeter because we're not going all the way around this rectangle, if we take our 2 x's, x plus this y, that's going to be the total amount of fence that John has, 100 feet. So even though, again, we're not talking about perimeter, I want you to think we are taking some length plus another length plus another length, and that's the 2x plus y. That has to be equal to 100 feet of fencing. The area of this dog pen is still going to be length times width, so we can take x times y. These are our 2 equations. We are trying to maximize the area, so the area formula is what we want to differentiate. But before we do so, let's take this perimeter, if you will, and let's get a variable by itself. Y is a good variable to get by itself. We just subtract 2x from both sides. And let's take this stuff that y is equal to and let's substitute it into our area formula for y. Substituting 100 minus 2x into y, we have x times 100 minus 2x. Go ahead and distribute. That gives us 100x minus 2x squared. And now again, we have a parabola that is opening down, so we're guaranteed to have a maximum here. You don't have to test that if you can remember some of the properties of parabolas. We have a quadratic. Its leading coefficient is negative. This parabola opens down, which guarantees you have a maximum. To find a maximum or minimum, we find the derivative, we set it equal to 0, and we solve for our variable. Therefore, a prime is equal to 100 minus 4x. We took the derivative of a. Let's set the derivative equal to 0. We're technically trying to find where the slope of the tangent line is 0. Oftentimes that's where you're finding maxes or mins. Now let's solve for x here. Subtracting 100 and then dividing by -4, we will get 25 is equal to x. Just solving that basic equation there. So therefore, x has to be 25 feet. This over here is 25 feet. And now you can plug 25 back into this equation, or you can just go ahead and say, well, if we got 25 and 25, that's 50 feet already, which means y has to be equal to 50. Giving us a maximum area of 25 feet times 50 feet, we have 1,250 square feet. So John can make a bigger fence. Granted, he uses the side of his house or the back of his house as one of the sides of the rectangular pen. As compared to what we did in example 1, if you have not watched that, John used 100 feet of fencing for all 4 sides. So again, the work does turn out to be a little bit different, and as you can see here, we do get a bigger area. As a matter of fact, we get twice the area. And that's not coincidental, it's just the way the numbers work. It's a beautiful thing. And there you have it, optimization, a very similar example to the first one we did, but again, you will run across this as well. In a future video, we may take this dog pen or a cow pasture or something, and we may break it up into 2 sections, and we'll explore that in a future video. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.